So now for our final segment, we're going to lift off. Before we lift off, we're going to hear from a gentleman who's become a good friend of mine just in the past year and a half or so. We met at another event in the mountains and found out that he was with this NASA program. And so our families went out to dinner, and Dante Lauretta started regaling me with stories of building a program with NASA, as well as conversations about philosophy and theoretical math. It's amazing that you even have to put the word theoretical in front of it, right? To qualify that. But so Dante, you're a professor at University of Arizona.
Correct.
And also lead a major program for NASA right now.
Yeah, the OSIRIS-REx asteroid sample return mission.
And just for full disclosure, it's important to note that the OSIRIS-REx name, you'll see an acronym later with a whole bunch of words in it, but that's not how the acronym came about, right?
That's right.
Yeah, so how did it come about?
Well, I got involved in the program in 2004. I was a young...
Right at the very beginning.
Right at the very beginning. I was a young assistant professor at the U of A, and with all of that entails, if we have any academics, I think the assistant professor years are the toughest years of your career because you're really trying to prove your worth, and there's a huge decision hanging out there whether you're going to get to keep your job or not. And then I got a phone call from the director of my laboratory, Dr. Michael Drake. He said he's got representatives from Lockheed Martin in the office. They're going to go after a NASA asteroid sample return mission, and they wanted me to lead the science program and be the deputy principal investigator. So I went home and I wrote down 4 words to kind of flesh out why would you go to an asteroid? What would be the reason to bring a sample back to the Earth? And the first thing I wrote down was origins. We're going to an ancient object, 4.5 billion years old, records the dawn of the solar system, and particularly the asteroid we needed to go to, we thought was organic rich and may have the seeds that led to the origin of life. And then I wrote down a technical term called spectroscopy, which is how we study most asteroids in the solar system. You look at how light is reflected or emitted off the surface, and you try to interpret that to determine its chemistry and mineralogy. And if you had a sample back, then it would make it a lot easier to do that job. And then in 2004, I thought it was being really kind of the sci-fi geek that I am, and I wrote down resources, thinking, man, someday if we fly this mission, somebody's going to look back and they're going to use this technology to develop asteroid mining. And then I wrote down security. We worry about asteroids impacting the Earth. Congress especially worries about this. Whenever they write a NASA Authorization Act, it always includes a big section on the asteroid impact hazard, and NASA is mandated to deal with that issue. So I had OSRS, and I said, well, that kind of spells out Osiris. I just need to buy a couple of vowels to fill out the acronym, and we love crazy acronyms in NASA's world. And Osiris really had the dual nature. The myth of Osiris is the bringer of life, the god of agriculture, and the founder of the Egyptian civilization, bringing agriculture to the Nile Delta, but he's also the god of the afterlife and judger of death, and asteroids have that dual nature. We think they brought life to the Earth, but they also wiped out the dinosaurs and represent a major natural disaster. And then the Rex part came later when we grew in scope, and I just thought we wanted to keep the Osiris name, but we wanted to be bigger and stronger, and we wanted to evoke those dinosaurs, and we made it Osiris-Rex, and I kind of filled it in.
Which also means king.
That's
so
right.
it's like you got the whole shebang.
Exactly, yeah.
Fantastic.
So.
Great. So I want to go backwards. I asked this question of Dory, too. What got you into the space thing? Were you dreaming about that when you were 5? Or what got you into the space thing?
It happened in college, really, in terms of deciding that I wanted a career in space exploration. When I started school, I was a first-generation college student. I didn't really know what college was going to be like. And I picked math as a major because I was good at math in school, and theoretical math. And I was very interested in a different kind of inner space, kind of the mind and how the mind worked. And theoretical math led to a lot of the philosophy of mind. But then I realized that was probably not a good career choice from a job perspective, and I needed something that I could go into. And I saw an ad in the school newspaper that said "Work for NASA." It was the NASA Undergraduate Research Space Grant Program. I got accepted into that program and assigned a project on the search for extraterrestrial intelligence. And I was like, people actually get paid to do this? This is the job. I want to have this job someday. I want to be out there looking for alien civilizations or exploring the solar system, and I just decided to go for it at that point.
Oh, wow. So coming up to today, OSIRIS-REx, you started 2004. The fellow that really got this going called you right at the very beginning. you got moving with him. You worked for how long? 7 years?
7 years of proposal writing and rewriting. And rewriting, as Dory probably knows, you don't win these big ones usually right out of the gate. It takes a couple iterations. And in the NASA world, there's a lot of competition for these mission lines. They're all competitively selected. We lost the first 2 times that we tried. And then on the third chance, we actually
And how
won.
big is the total mission from a dollar perspective?
The mission is about $1.2 billion, all included, including the rocket, which we paid $183 million for.
So you didn't put it in your
Right?
shopping cart?
Right? No,
and-
no. We paid full price. You buy down a lot of risk there, though, Naveen. Just remember that. So with $5 million, you're not buying the risk reduction. So there's that side of it. My budget that I manage is about $840 million.
And so your team won the award back in 2011, right?
Correct.
And then something happened.
So Mike Drake, who had been my mentor and my advisor and a father figure to me, we won in May of 2011, and he had been ill through most of 2010, and in September of 2011 he passed away. And it was a major blow emotionally to me, to the team, and I went to visit him in the hospital right before he passed, and I was worried. I mean, I was still, at that point, not even 40 years old and supposed to be taking on the helms of this NASA mission. And he gave me the confidence to go. He's like, you have to take this forward. I believe in you. You're the one that's going to lead this. And we said goodbye at that point, and I knew I was gonna follow in his footsteps, and then we do everything we do in his honor and his memory.
All right, so he'll come back to this story a little bit later. So you win the award, you start to build the probe, the analytics, the data, and what if you could summarize briefly, what's the objective of this OSIRIS-REx mission?
So we are going to send a robotic spacecraft on a 7-year journey to rendezvous with near-Earth asteroid Bennu. Bennu's interesting for several reasons. It looks like it's very rich in carbon, and we hope it holds clues to the origin of organic molecules and the origin of life in the early solar system. It also looks like it would be a really good target for asteroid mining in the sense that it has water-rich minerals in the form of clays that you can process into rocket fuel. And then also it has a reasonably high probability of impacting the Earth. We put the odds of an impact about 1 in 2,700, which sounds pretty small. You would, cross the street with those kinds of odds, as I like to say. But, it would be a major natural disaster, and so we're interested in understanding the likelihood of that event occurring and any technologies we could develop.
To digress a little bit on that, I was surprised when you explained, maybe I wasn't paying attention before, but you explained to me that a lot of asteroids have clay and carbon, and I always have the stereotype that it's the iron with some, with a few other things thrown in there. But there are actually a lot of carbon-based, a whole variety of different kinds of asteroids.
Yeah, there's a huge range of asteroid compositions. You got to remember these are the rubble left over from the dawn of the solar system. So think about spreading all of the rocks on Earth out to the orbit of Jupiter. And this is just the stuff that's managed to survive the chaotic, dynamical evolution of the past 4.5 billion years. So there's an even wider diversity of rocks out there than there are on the surface of the Earth.
So you shared, and Doyle and I were chatting about this earlier. There was you might recall in the news, it was a big deal about how some scientists felt that there might have been galactic microbes in one of these that had landed on Earth, and that turned out not to be true, but something exciting happened as a result of that.
Yeah, so I think you're referring to 1996
Yes.
And a meteorite called Allen Hills 84001, which was recovered in Antarctica and determined to be from Mars. And a group of researchers led by a team at Johnson Space Center published a very careful paper when you go back and read it, but it concluded that there was evidence that there was fossilized microorganisms. Therefore, life had originated on Mars, and therefore the origin of life was a common event in the universe, and so it's a ground-shaking hypothesis. I remember I was still in graduate school when it was announced, and President Bill Clinton had a press conference, announced this discovery of ancient life on Mars. And really, in time, that's kind of been overturned. We don't believe those features are really fossilized microorganisms in that meteorite. But it launched a whole field we call astrobiology. It kind of legitimized it. Also, the Mars program in general. We've had a spectacular Mars exploration program since the late 90s that can be traced directly back to that discovery.
So this discovery that turned out maybe to be a little specious, it turned out to actually catalyze a whole lot of other.
Absolutely. I think it legitimized a lot of our work. So I mentioned I started off in the search for extraterrestrial intelligence. And in fact, one of my advisors at the university absolutely forbid me to go into that as a career. He said, that's death to your academic career. Nobody will take you seriously if you do that. So I figured I'd have to find kind of the back door into understanding if there was life out there in the universe. And planetary formation was a legitimate area to go into. How did planets form? Something that was really taking off in the late 90s. We started getting Hubble images of the Orion Nebula and seeing protoplanetary disks for the first time and piecing together the geologic history of our solar system. And then with Alan Hill's 8401, the idea that you could legitimately study the origin of life on another planetary body became real.
So, by the way, and I want to shift back now to the program and give us a little bit of background of how you got to where we are, and then we'll talk about where it is now, and then the end, this is the big finish, we're actually going to do a launch. You're going to be in the room, well, not really, of course, but imagine it's a virtual reality space, and we're going to do the launch later. But before we go to that, I'll point out, I think Michelle Larson is still here, the president, there she is, the CEO of Adler Planetarium and a planetary expert. Happens to be with us. So thanks for being with us, Michelle. That's great. So the program, what were the key points moving up to it? And before we do that, I'd like to cue a first very brief video showing a little bit of the probe. So if we could cue video 1. So what's this?
So this is one of the camera systems. We called that red protective cover the Iron Man suit whenever we were transporting it, so the optics wouldn't get damaged or anything like that. And that's the science deck of the actual OSIRIS-REx spacecraft right there. There's the vehicle coming out of one of the test chambers, so we put it through a whole battery of environmental tests to make sure it can survive the radiation, the thermal.
Is that a test chamber?
That's a thermal vac chamber right there where we're dropping it into. So this is the vertical integration facility at Launch Complex 39 at Kennedy Space Center where we launched. That's the Atlas V rocket.
You lived down there for 4 months.
I did, yeah. I got to fly in on an Air Force jet to accompany the spacecraft. We built it in Littleton, Colorado at the Lockheed Martin facility there. And then we drove it over to Buckley Air Force Base. We got onto a Globemaster cargo jet and we flew from Buckley to the shuttle landing facility at Kennedy Space Center. It was pretty amazing.
So what would you say is one of the key turning points or moments in the development up to before the launch?
Certainly when you get past your critical design review, that's like a big deal because at that point you're going from PowerPoint to hardware, and it's hard to explain how important that is, but you spend years looking at PowerPoints of the designs and discussing literally every nut and bolt and fastener, whatever's going to go on there, you go through it in gory detail. And after critical design review, the experts have looked at it, NASA has approved it, and the team is go build hardware and start delivering it into the facility.
So now let's fast forward to where we are now. Where is the probe approximately at this point? Or maybe you know exactly. I'm sure you do. And then what is it going to do? And we'll share a video and you can explain it and then build from there. So let's cue video 2.
Yeah, so we launched in September of 2016, and we have been traveling towards asteroid Bennu for the past 2 years. In August 17th of this year, we crossed the 2 million kilometer threshold, which is where we could get the first image of the asteroid. It was just a point of light, and we've been closing in on the target ever since then. We expect to resolve the asteroid in late October, and then in December of this year, we'll actually enter into the vicinity of the asteroid and begin the geologic mapping. Here, the green circle indicates the asteroid. That was the first light on our telescopic imager. There's also a shot of the Earth and Moon as we came back to the Earth for a gravity assist and then turned around and took that picture on our way out.
How shockingly, utterly insignificant we are. We can't even, we're just a small speck of light.
Yeah.
40 million miles away.
You had Carl Sagan kind of kick us off here, and I was also heavily influenced by Cosmos as a kid. And the pale blue dot, you always go back to that, and you just think about that quote and all of the turmoil, all of the wars, all of the hatred, a lot of that goes away if people can get above and look at the Earth as this oasis in space, to understand how precious it is, how unique it is, and how important it is that we work together to make it a nice place. Dorit mentioned that we're destroying the Earth, and I always like to remind people the Earth's going to keep going on. We're not going to destroy the planet. We're just going to make it a pretty ugly place for humans to live. I think there's a key difference there.
So nearing the launch now, we're heading up to our big grand finale for the evening. Give us the brief segments right before that 10-9-8 that we all know from the movies.
Yeah, so when we're at Kennedy, one of the best parts for me, being the super geek, space geek that I am, is I got to watch them assemble the rocket, right? So they bring the first stage in, they bring the second stage in, and then ultimately the fairing, which is the nose cone, comes in and encapsulates the spacecraft. That's the last chance that we get to see the vehicle with our own eyes. And that's kind of a bittersweet moment because I kind of grew up with this spacecraft, and I hung out in the clean room where they were building it. And there were days where I would be there with the lab techs and the engineers as they were assembling the machine, and you'd have some downtime while you're waiting for a test to be approved, and it was like they'd have rock music blaring, and it was like you're hanging out in your buddy's garage, except you got an $800 million spacecraft that's sitting right behind you. And they're fascinated with it. One of the
Was anybody
parts,
like Brad Pitt there or somebody like that, in the control room with you?
Yeah, absolutely.
Brad Pitt?
Not somebody
Angelina
like Brad
Jolie,
Pitt.
maybe?
Somebody like
Okay,
Brad
all
Pitt.
right,
Depends on which character we're talking about.
Yeah, okay.
Anyway, so at Kennedy Space Center, I got to watch them assemble the entire rocket. I had free access to that integration facility. I had the badge that got me in, so I could crawl up and down and look at every component of the rocket. And I went through the checklist with the engineers. So most people don't know, but the checklist starts, hours and hours and hours before.
How many
the
hours?
At least 12 hours before.
12 hours in
You're
advance.
starting to go. They're launching weather balloons across the Atlantic, right? They're flying jets. They're looking at the upper atmospheric winds. They're starting to go through all the detailed subsystems. There's hundreds of people that are going through their component to make sure that it's in proper working order. It's going to do its job so that the entire system can work.
So that 12 hours before, at some point you're driving to, how are you feeling?
So I got up early that morning and I went out to the beach and watched the sunrise, it was a real profound moment for me. It was, at that point, 12 years of my career had led up to a giant pile of explosives, basically, that everything needed to go right in order for the work to continue. And I drove in. It was a beautiful morning. We had just had a massive storm come through, major rain. A hurricane had actually ripped up the west coast of Florida and then crossed over and went up the east coast through the Carolinas. And then the weather just cleared. It was gorgeous. We actually made a joke because we're all from Arizona. All the Arizonans showed up with our dry skin, and we sucked all the moisture out of the Florida atmosphere. So it was beautiful, clear sky the day of the launch. And I thought about Mike a lot, because he would have loved it. I mean, he absolutely would have been a crowning achievement of his career as well. And so it was kind of, profound for me. I felt like he was there with me, and we were going to take this thing on its journey like we had talked about from day one.
Well, Dante, he probably was there in a sense. What concerned you the most leading up to that 10-9-8 sequence?
Well, I had thought about, first of all, the thousands of people around the world who had worked to make that machine, the spacecraft and the rocket, and then all of the support equipment that goes along with it. I mean, and people were really invested in this. I mean, this mission gets people excited. It's a great adventure, a science adventure, a treasure quest to bring back something from the early solar system. And so everybody's dreams would be crushed if something went wrong, and catastrophically wrong especially. And then I thought about the couple hundred people that were going with me into the operations phase, and all their jobs were kind of hinging on this thing going well today. So I was worried about my team. I wanted to make sure that everything went well for them because they had worked so hard to make this thing go.
So in the video we're going to see in a minute, and we're almost there. You're going to see the control room. And by the way, it looks just like all the control rooms you see in the movies, and all the people behind the screens, and everybody's looking, probably, like 100 people sitting in this room?
Yeah, and that was only one room. We had several other rooms where
Okay.
the other engineers were also looking at their components.
Okay, so everybody's looking at the screen, and you explained to me earlier that each one of those stations reflects somebody with control over a specific system or subsystem.
That's right.
And they each have to sign off on their own subsystem to make this happen.
And that's happening for hours and hours and hours before you get to the 10-9-8 sequence, right? And by the time you're there, you're going, unless something really, really bad happens.
Great. So I want, as we go through this last sequence, I want you to actually be an actor for a minute and Imagine you really are there and you've invested 12 years of your life and probably the next decade of your career in what will come back from this probe. And I want you to reflect briefly on the fact that where we are today, having barely stepped foot on the moon, is probably where the Portuguese and Spanish were when we had visited the Azores and weren't even sure it was on the other side.
Right.
We're just at the very beginning. And feel that when you watch this video. And incidentally, make sure you're at the MCA, the Museum of Contemporary Art, tomorrow by 8:30 a.m. and don't be late. That aside.
Right.
Imagine this moonshot, or as our good friend Safi here says, loon shot, another book you'll hear about at some point. Imagine all the war, turmoil, and hatred that Dante mentioned in the pale blue dot, but also, of course, the inspiration, the aspiration, the commitment that this sort of endeavor takes, and I dare say love. So with that, let's turn up the volume and imagine you're there in the room, and here is the launch of the OSIRIS-REx.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid belt and back.
Altitude is 14 miles, downrange distance 9 miles, current velocity 2,488 miles per hour.
Dante, last word.
Yeah, just a note, you noticed that the announcer said to boldly go. It was the 50th anniversary of the first episode of Star Trek on the day that we launched.
Was that a coincidence?
It was, actually.
Really?
Yes, it was a coincidence, yes, absolutely. We couldn't pick our launch date. So,
well, Dante, Dorit, Naveen, thank you so much for sharing your passion with us. It's infectious. I want to point out that this visual of Earth is from the probe. And you'll notice Brian Stevens, our AV lead, who does such a great job, and he and his team pointed out to me the top is some incomplete data.
Yeah.
Is that right?
There's a couple things I really like about this picture. It's centered on the Pacific Basin. And, you know, I imagine, in fact, I gave a talk at the Lunar and Planetary Science Conference about this data set. And if you were an alien probe and you just did the flyby the Earth and all you got was this shot, you would have no idea there was humans on this planet. In fact, I repeated Carl Sagan's famous life detection experiment, and the only thing we could find was the photosynthesis signatures. Really? But the noise at the top there is because we designed cameras to take pictures of an extremely dark asteroid that's rich in carbon, and the Earth is much brighter than that, and we couldn't read the detector out fast enough to get all that signal down.
To me, it shows an Earth from which we recede, a vision that is totally different than our experience for all the history of humanity. An Earth as well that is digitalizing, that is being turned into a digital experience as we recede to eventually our children on Mars and the moon and beyond. Thank you so much.
Thank you.